Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. Hopefully you will see my stream has started. Last week we had some problems because I selected the wrong video to stream to. Today we're going to be looking at functions, which will carry on mostly from what we did last week. Last week was an absolute beginners session, so if you're new to Python, definitely come along to the first Tuesday of the month, and that's when we do for absolute beginners. But and the other days of the month we do more advanced stuff, but we're still happy to accept questions from absolute beginners then as well. We're going to use Google Colab, which is a way of running an interactive Python online. It's a very powerful facility provided by Google, and it's free, and all you need is a Google account to use it, and that means you don't need to install Python on your computer. And being interactive, it really helps to you learn, because you can type commands in and get a direct response. So to fire up Google Colab, you'll see in the meetup here I've provided a link to colab.research and a particular notebook that we'll be looking at tonight. If you're looking at the video on YouTube, if you look in the description down below the video, you'll see I've also got the same link. So click on that link and fire it up. Now we've got quite a number of people sign up for tonight, so I hope you're all watching and understanding. But if you've got any questions, I'd love to hear them. You can try the questions on YouTube chat, or you can try, use Slack channel. We've got a Slack channel here, so it's Beginners Python, Machine Learning, and Learning to Code is the channel where you can put your questions. That's what I'll be monitoring. You can see I've put in the link for today's video there as well. If you haven't got connection to Slack, send a request to skypi@gmail.com. I think the instructions are in the YouTube description as well as in the meetup description. So if someone could just respond to make sure that the audio and video is good, that'd be great. So we've got a Google Colab notebook here, and the first thing I'd recommend doing is clicking on this copy to drive. You can click on it here, or you'll find it in the file menu, save a copy in drive. And once you've done that, you'll keep a copy forever with all your changes that you've been making. And so that's the first thing I'm going to do. I've created a copy, and so that'll open a new link. As you can see, it'll give it a new name. Alright, thanks David, good to hear you can hear me. So you see up here in the title it says copy of meetup 128 functions for intermediate. You can rename that just by clicking on there if you want to. I'm just going to leave it the same. Now I'm going to share this link as well, so if I've typed stuff in this notebook, you can use this link to get any updates that I've typed. So I'll post that on YouTube and in Slack. Alright, now a notebook is made up of text cells, so you can put formatted text like this, and there's another text cell here, or you can have code cells. And there's the third one's another text cell, and then here we have a code cell. And you can see at any point you can insert another code cell, or you can insert another text cell. Is there anything here that I should? No, that'll do. Alright, so last week we defined a function with one argument. So def is a Python keyword that says we're defining a function. We gave the function the name f, and in parentheses we had one argument which we've called a. Now the function was return a squared minus 4a plus 4, and then we did some work in that function. Now today we're going to try different data types being sent to this function and see how it behaves. And this is really going to demonstrate a lot of the dynamic typing that's available in Python. Okay, now to run this code cell, you have to click on the play button here, or you can type Control Enter, or you can do Shift Enter. If you do Shift Enter, it'll take you down to the next cell after you've run it. So I'm just doing Shift Enter. The very first one that you do, we have to initialize a whole workspace here on the Google computer. And once that's ready, they've given us a certain amount of RAM and disk space. We don't need anything fancy. We don't need GPUs. We don't need extra RAM because we're just doing simple stuff tonight. All right, now the first thing we're going to do is put some values into this function and plot the results of those values onto a plot, and we're going to use Plotly Express as our third-party graphing library to do that. So we have to import Plotly Express. Now this is a third-party library. Normally it's not installed when you have Python, but Google Colab is going to give you all the libraries that normally come with Anaconda, and Anaconda is a collection of these third-party libraries. If you weren't running Google Colab, if you're just trying to run this on your own computer at home with a Python installed from python.org, then you'd need to install Plotly itself. So if anyone's doing that, put a comment in and I'll run through the instructions on how you can install Plotly. Okay, so we're going to create two lists of data. So you remember that a list in Python is enclosed with square brackets. So we're going to have a list of x values and a list of y values. We're going to use list comprehension to create these lists. So the way that works is we have the value that we want to put in the list, and then we have a loop of a for loop that's going to give us that set of values. So the for loop's going to be, I is going to be in range 41, so that's going to be 0, 1, 2, 3, 4 up to 40, but not including 41. And then we're going to divide it by 10, so we're going to go from 0 to 4.0 in our x values, and then our y values are going to put those same values and run them through our function. So I'll execute that cell, and you can see Plotly has created a nice graph for us. It's got a lot of cool features on it. We can hover over any of the points in there, so you can see when x is 0.3, y equals 2.89. When x is 0.4, it's 2.56, and it goes all the way up to x equals 4, y equals 4. And you've got a few controls here. You can zoom in, so I can select a vertical range like that and zoom in that way, or I can select a horizontal range, or I can select a rectangular range. Once I've zoomed in, I can pan around by dragging, so I'm clicking and dragging at the moment. So yeah, there's all fun things we can do, and then we can just reset it back to how it was originally. So that's our quadratic equation. It's your typical parabola that you would expect. Okay. And I've left a blank cell here for some reason. Who knows why? Okay, so we've used floating point arguments going into being passed into here. So I divided by 10 is always going to be a floating point number, and so all of these values are floating point numbers. But there's another class in Python. This one comes from the standard library, so it doesn't need to be installed, but it does still need to be imported, and it's called decimal. When you use decimal, you don't have the issues with floating point rounding errors that you get with the normal floating point class, but it is a bit slower. So if you're doing lots of scientific calculations, you're probably best to use float. If you're doing accounting type applications with not so many calculations required, then you can use the decimal library. So in this case, we'll take the value 1.1, and to make a decimal out of that, we have to enclose it in a string. If we don't enclose it in a string, then it starts off being a floating point number, and you've immediately got your rounding errors in there. So to avoid those rounding errors getting there, it should never be a floating point number, so we keep it as a string, and then Python decimal library can analyze that string to convert it straight into a decimal number. So let's run this cell, and I've printed out some results here. So the type of X is decimal, and the type of Y is decimal, which is Y is just f of X, and f of 1.1 gives us 0.81. Now I've used F strings here for formatting the results. If you don't understand that, just ask a question. I'll go through that in more detail. These are a fantastic way of displaying results, and using F strings. Python over the years has had other sorts of formatting that you can use, but these F strings I think have been the most versatile and can be used in just about every situation. So I just concentrate on using one way of formatting data in strings and forget the others, and that way you can get very proficient at this particular way. You can do things, anything to the left of the colon is the value you want to display, anything to the right of the colon is the format you want to display it with, and that applies to anything that's in these curly braces. Anything outside the curly braces is just straight text. Alright, now let's look at the results, and you can see these floating point errors that I was talking about. So X is a floating point number, Y is floating point, so f of 1.1 is 0.809999 up to 6. So very close, but not exactly the same. Okay, so try other data types for an argument to a function. So for example, complex numbers. Now, Python can do complex numbers, and the way you use them is you use this J. So J really represents imaginary numbers, which is the square root of -1. So if you remember from your high school maths, you can't take the square root of -1, so anything that purports to be taking the square root of -1 is imaginary. Well, it turned out the mathematicians can do something with that, and so they call it, I've often said it called I, but in Python they call it J, and for the imaginary numbers, and we just say 2J in this case to say our imaginary part is 2 and our real part is 5. You notice there's no multiplication sign between them. You possibly could put no, I don't think you can put a multiplication sign in there. It's by that format it knows that it's a complex number. So if I said C equals 5 minus 2J, and I say, tell me what C is, and Python has stored that as a complex number. And so I can say what's the type of C, which is another Python function, and it says it's a complex number. So it's not floating point, but the real and imaginary parts can be floating point or integers. Okay, now we want to pass it through to the function. Now we designed our function to use real numbers, but there's nothing in it that we said it could only be real numbers. So if someone gave it a complex number, 5 minus 2j, we'll actually get a result out, 5 minus 12j. So I'd recommend you try typing these things into the cell and try a few different things in there so that you get a feel for how Python's going to react. I still use it today. I'll always type something in and see how it responds. Okay, so here's a solution here. We're storing 5 minus 2j into x. In y we're storing we're calling the function f of x and storing the result in y, and then printing out the result using that format string. And we can see x is complex, y is complex, and f of 5 minus 2j is 5 minus 12j, which is what I got there. So I mean, try different values as well, so you can get a feel. Let's try 5 plus 3j, and the full answer to that's 18j. How about that? So let's try 6. 7 plus 24j. All right. I've got another solution one here, which is using a different data type. So here we tried complex numbers, which is what the original task was. Was any other data type, but it gave an example of complex numbers. But we could also have used an ND array from a third-party library, NumPy. Now, if you're doing data science, you'll be using NumPy quite a lot. So this is a pretty useful one. In this case, it's a third-party library, so you need to install it, but it does come with Anaconda. And we're going to create an array of numbers, so floating point numbers that are going from 0 up to but not including 2.1, going up in steps of 0.2. So let's have a look at what that looks like. So the type of x is a numpy.nd array, and the values, they've used square brackets here, and it's going 0, 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4. So you can see it's starting from 0, going up to, but not including 2.1, and it's going up in steps of 0.2. So that's useful. It means you don't have to do that I divided by 10 that I was doing in my list comprehension before, and it gives you these values. Now, a NumPy array actually understands the operators, asterisk for multiplication, minus for subtraction, plus for addition. So I can just say x times x. Now you can't do that with lists, but with a NumPy array you can do it, and it takes two of these arrays and multiplies the first element in both by each other and gives you the result, which is 0. Then the second element in both gets multiplied together to give you 0.04, then 0.16, 0.36. So you can see, because NumPy arrays understand these operators, we can pass it straight through to the function and it will do the calculations. So all you have to do is this one line, y equals f of x, and it does it very quickly. We don't have to put loops in or list comprehension, and it will say the passing in this array to the function will give us a result of that. Which is what we'd expect, because that's the first half of that curve that we plotted before. All right. So what other data types can you think of that you could possibly pass to this function? Now, some people like to use rational numbers. So remember, rational numbers are any numbers that can be expressed as a fraction. And Python actually has a standard library called fraction, specifically to deal with these rational numbers. And once again, you create them by putting the number into a string, and then Python converts it, finds the numerator and the denominator from that. So let's have a look at what it does with that. So x is of type fraction. When it displays x, it displays it as 1/3 rather than 0.33333, because you know that that's a never-ending repeating decimal, and so you can never express it to, exactly as a decimal number, but you can express it exactly as a fraction. And so when you pass a third into that function, x squared minus 4x plus 4, the result you'll get out is 25/9. So that's pretty cool. Now we know that's going to be an exact answer. If we pass it through as a floating point number, we're going to get an inexact number. Even if we pass it through as a decimal, there's no way we could represent 1/3 as a decimal exactly. So our result here would not be exact. So I thought we'd try some even more fun things to do. There's a third-party library called SymPy, which also deals with rational numbers. And so we're going to import SymPy, and what's a common thing to do is when you import SymPy, you just import it as SYM, so you don't have to type SymPy every time. You can just type SYM. So that's all that as is. It just creates an alias for us. So we're going to create an alias. We're going to create a rational number. This time we're going to do 2/3, and they use the string way of putting numbers in as well. I think you can actually also specify a numerator and a denominator as arguments to rational when you're creating it. Then we're going to pass this rational number into y, and let's see what we get out. Looks very similar to fraction, and this time it's rational rather than fraction, and f of 2/3 is 16/9. So that's pretty, as we'd expect, very similar to using fraction. But SymPy can also do some things like producing a very nicely formatted output. So if you remember up here, I'm just going to run this one again, and I'll create another code cell in here and say tell me what the value of y is, and y comes out like this, fraction 25,9. But now if I run using SymPy and I do the same thing and I say tell me what the value of y is, it works out that we're in Google Colab and works out a really fancy way of displaying it. So it does 16/9, which looks really nice. SymPy is also useful if you want to create irrational numbers. So these are numbers that can't be expressed as a fraction. So examples of that are square root of 2 is an irrational number, and pi is another irrational number. So they'll have an infinite number of decimal places, but they also cannot be expressed as fractions. So let's look at what happens to our function. Remember, which is just the quadratic equation. When we pass in irrational numbers using this SymPy library, and the result that we get is actually a very nice looking irrational equation. So I bet you think, I wish we had this when I was at high school and had to do these formulas with irrational numbers and come up with exact answers. So this is an exact answer to the formula and can be useful for things. All right. Oh, yep. So another thing we can do with SymPy is we can create the formula into symbols. So remember that function was x squared minus 4x plus 4, which we created by x times x minus 4 times x plus 4. Now we can store that as symbols in y. So when we display it, it actually looks quite nice in the way it's displayed. And then we can do other things with it, like we can do calculus on those functions. So for example, we can differentiate using sim.diff of y. So that takes dy dx of x squared minus 4x plus 4 gives us 2x minus 4. So if you're struggling with your differentiation, you can just use the SymPy library to do that for you. We can also factorize the polynomial. So this is the polynomial here, x squared minus 4x plus 4. And we call the factor method in SymPy, and it says, well, that's actually x minus 2 all squared. We can solve it exactly. It's a quadratic equation. Solve it for y, and it's come up. It's got a list of solutions, but in this case there is actually only one solution, which is x equals 2, gives us y equals 0. Now sometimes you might want to display these equations nicely, and the SymPy library can convert it to LaTeX for you. So for example, if I do sim.latexy, it tells me that's what the LaTeX version of it is, and so I can take that LaTeX version there and I can put it into one of these text cells. So I've just double clicked on that text cell, and this uses a markdown library, markdown format, and to put LaTeX into markdown you surround it with these dollar signs. So I've just taken this bit of text here that came from sim.latex, put it between dollar signs, and then when I do shift enter on that one, it converts it back to a very nicely formatted thing. So that's how you can put mathematical formulae into your markdown cells, so that when you're documenting stuff. So everyone's been very quiet tonight. I haven't had any questions yet. I found this a lot of fun, playing with all these things, and it was really surprised me that I could use a function in this way to get all these different bits of information out of it. Alright, so we'll move on to the next task. Create a function for the sigmoid function using exp from the Math Standard Library, and plot the function with x values from -5 to +5. Alright. So we have to use the Math Standard Library. So that's import math. Then we want to define a function, and we call it sigmoid of a, and then we put a colon at the end. So remember, the a is in the parentheses. We have to put a colon, which means we're about to start a code block, and when we press enter after the code block starts, then we can it will automatically indent for us. On mine it's indented 4 places. If you've just copied my notebook, then you probably will get it indented 4 places as well. If you're just using Google Colab by itself, I think it defaults to 2 places. It all works, you just have to be consistent all the way through. Okay, so we want to put in the function 1 plus math dot exponent. So there's our library name, math, and here's our function name in it, the exponent, and minus a. Alright, then we'll plot the value, x values from -5 to 5. So our list of x values, we'll use list comprehension. We'll go up in point, let's see, we'll go I divided by 10 will do for I in range. We'll start at -50, we'll go up to 51 because it's up to but not including 51, and we're dividing by 10, so that should be good. And then list of y is going to be all our y values, and that can be, let's go sigmoid x for x in list X. And then we want to plot those. So we imported plotly express before, so we can still call it here because we ran it up the import in an earlier cell, and Google Colab remembers everything that we've run earlier. Our X values are stored in list X, and our Y values are stored in list Y. And you can see here I'm using named arguments in the function. So up until now we've been using positioned arguments, but because I don't know what the position of X is and Y in the line function, I can name them, and then I know it'll put them in the right spot. Alright, so px.line, and we can see these are all the values that use the sigmoid function. So sigmoid's a useful function you'll use in machine learning. It converts all your values into a range from 0 to 1. And yeah, sometimes I've seen it used where it's displayed slightly to go from -1 to 1. But that's what it looks like, and we had the formula. So let's have a look at the solution. The solution is pretty similar. We just did the list comprehension for Y slightly differently, but that works as well. Yep, gives exactly the same result. Okay, I've got a comment here from Liu Chung Kai. It says, never thought to calculate like this. It's cool. I think it's really cool too. Alright, so we've task 3, try calling that sigmoid on a NumPy array. And in fact I've put the solution here as well. So let's see what happens if let's run this, and it says only size 1 arrays can be converted to Python scalars. Alright, let's I'm going to create another code cell and we'll just do it. So we've created X, so let's see what X looks like. There we go. It's an array going from -5 up to +5, going up in 0.2s. So that's good. Let's have a look at what Y looks like. Oh, actually, let's just try running this. Y equals sigmoid X. And I get a type error. Now, when I create these notebooks, I don't like having type errors, because sometimes people like to run them, and you'll see in runtime you've got a menu, you've got to run all. Well, that'll work until it'll run all the cells until it gets to one of these that has an error in it. So I don't like to have an error just sitting there knowing that it's going to break. So what I've done in Python, you can catch these errors by using a try except statement. So try is the command you want to try doing, and if an error occurs in this code block in the try part, then it will go down to the except bit, and the except bit, if it's that particular error, if it's a type error, not if it's any other type of error, but if it's a type error, it'll actually catch it and not create an error. All it'll do is it'll print, well, in this case I've said please print what the error is, which is only size 1 arrays can be converted to Python scalars. So I could decide to do something else about it, but if you look here, if you let it happen, then you'll get, it tells you where the error occurred. It occurred when we tried to call sigmoid. It then looks in sigmoid and says where the error in sigmoid occurred, which was on this line here, and the answer was only size 1 arrays can be converted to Python scalars. And what that means, if you remember, a scalar is a single value, and so the math library that comes with Python, the exponential function that's here, it requires a single value. Now there are other values, like you've got vectors, which is our NumPy array as a vector, which is a 1-dimensional array of values. You can have a matrix, which is a 2-dimensional array of values, or you can have a tensor, which is 3 or more dimensional arrays of values. Okay, so task 4 here is giving us a suggestion. Try doing the same function, but use numpy.exp rather than math.exp. So the numpy library actually comes with a exponential function that can be used instead of the math library function. So let's grab our function. And we're going to use numpy.exp. Now I think when we imported numpy, we imported it as np. So we just have to type np. It actually won't work if we type numpy because that's how we imported it. And let's try running sigmoid of x. Oh, so x was supposed to be this numpy array. And that's the same, yeah, that's the error. Yep. So sigmoid of x. There we go, sigmoid of x worked. So because sigmoid's now using this numpy version of the formula, it now works and can it can take an argument that is a vector or a matrix or a tensor. So the reason that our array could be used in our polynomial function was because when they're writing when they're creating these classes like numpy array, they can override those operators, any of those mathematical operators, but they can't override a function. So you really have to use the right function in the in your function to start with if you want it to work. So I just ran it there. Let's have a look at the solution. So the solution is going to use okay, in our solution we've tried it with a scalar. So using numpy exponential with a scalar, and the scalar was -2, then we get a result which should have been, oh, here it is printed. There's the scalar. So it works with a scalar. Here then we're going to use a matrix. So it's a two-dimensional array, and that produces a two-dimensional array as a result. And here we've done it as a vector, and that's a one-dimensional array, and it gives a one-dimensional array of results. And then we've plotted the results. This time we've plotted them from -10 to +10, so it's, you can see the plot is a bit more compact. Alright, so this is really valuable. If you can run a formula like this on an array, it's a lot, especially using NumPy and Pandas, then you'll find it's a lot faster than using Python loops. So when you've got a lot of data, this can make a big difference to how quickly you can process it, because they're all written in C and optimized for this sort of thing. Okay, so that's enough of using different data types in functions. Let's move on now. So task 5, define a function which converts temperature in Celsius to Fahrenheit. That looks pretty easy. Define a function. I'll just call it far of a Celsius value. Colon, start a code block, and we just want to return C times 1.8 plus 32. And we just check it works. Fahrenheit, if I spell it right, the value for 212 degrees, actually for 100 degrees in Celsius should be 212, and it is 212. So that's just a standard how you define a function. You should be you've seen a few functions here tonight, so you should be getting pretty familiar with how to write a function. We've just been doing one-line functions, but you can put several lines in here as well. Okay, we'll have a look at the solution. Solution's used a bit more verbose. This variable name, the argument name here is put in the word Celsius, which is probably a good thing. It makes it easy to understand what it is rather than C. And then we've tried calling it for different values of C, 0, 100, and minus 40. So let's see what that goes. So 0 degrees Celsius is equivalent to 32 degrees Fahrenheit. 100 degrees Celsius is 212 degrees Fahrenheit. And minus 40 degrees Celsius is minus 40 degrees Fahrenheit. Alright, so that's a function with one argument, but you can have more than one argument in a function. And those arguments can be identified by their position. Here's one way of doing that. So for example, print. We've been using mostly one argument print statements, but you can do 3 arguments, and you separate the arguments with commas, as I've done here. So here I've got 3 arguments. The first one's a string, the second one's an integer, and the third one's another string. So example of print with 3 arguments, and then a space, and then the 2 gets printed, and then a space, and then the word 3 gets printed. So how print works if you've with multiple arguments is it just puts spaces between the values and then prints it all out on the same line. Alright, now this is what we've normally been doing. We've been using these F strings, and you can see there are no commas outside of the F string, so it is really just one argument. And I've put S1 here as example, so that string is example. It gets substituted into the curly braces. And we go example of print with one argument. You see the 3 minus 2 got calculated to 1. This argument is string, which is the result of a format string being evaluated. Alright, that was pretty boring because we've done a lot of format strings already. Now, functions can also have named arguments. As you'll remember, we did in px.line, we named our x and y, and print is also has named arguments. So as well as specifying your positional arguments, here's what you want printed, you can also specify these named arguments, which is how you want it printed. So your positional arguments have to come at the beginning, your named arguments at the end. And in this case we've specified the separator rather than being a space, we want it to be a dash, and the end of line rather than being a new line, we want it to be a space. So if we run that, we get these first 2 lines are with no named arguments, and then this last one you can see example of print with dashes between it, and then it doesn't drop a new line before the next print statement. So you can always put end equals something, end is space or end is nothing, if you want it to if you want the next print statement after this one to stay on the same line. And there it is with named arguments. This time it's got underscores as a separator, and then the end of line is less than, new line, less than, new line. So let's have a look at some of the built-in functions that use positional arguments. So for example, min finds the minimum of a list of numbers. Max finds the maximum of a list of numbers or letters, and anything really that can be compared, it will find the min or max of. Sum just takes one argument, but that argument can be a sequence. So it could be a tuple, it could be a list. Here I've used a tuple, which has got the parentheses around it, or I could have used square brackets for a list. So we see min 2.5, it could 2.5 out of those 3 numbers. 83.4 is the sum of all of those numbers. ACG is the maximum of those, and that's because in the Unicode alphabet, all the lowercase letters come after the uppercase letters. And you see max can work with either individual arguments or one argument, which is a sequence. Sum doesn't work with individual arguments, you have to give it a sequence. All right, now if you want to find help on these things, you can use the help command in Python console, or we're in Jupyter Notebooks here, so we're got a few more features over Python console, but we can still use this one. So help sum, and you can see it takes an iterable and then a named argument, which is basically what you'll want to start from. So it'll add up these values and add it to the start value, which I guess means you might be able to do sum of just two numbers. All right, if you're in, I'll do another code cell. Because we're in Jupyter Notebooks, the other way to find help on sum is to do a question mark and then sum, and that'll bring up this panel on the right hand side, which gives you the same information, and I can just close it when I'm finished with it. Now you can see here when I'm wanting to do something with the function rather than call it, so the function is called sum. If I wanted to call it, I use parentheses after it, but if I want to do something, in this case I want to find help on it, then I use the name of the function without the parentheses. All right, let's have a look at some, methods of functions attached to classes. So we've seen just standalone functions up until now, but some of these classes have a function built in. So string is a class, and it's got some built-in functions to the class, so they're called methods. And the way you call a method is using this dot notation. So you've got a variable here which has got a value in it, and I don't know that we've set my string yet, have we? Let's try running that. No, my string is not defined. So let's set my string to something. And what are we doing? Oh, converting to uppercase. So let's go my Camel Case. So I've got a string here which is in Camel Case, so it starts off with a lowercase, then it's got uppercase values at the beginning of each word within it. We can convert that all to uppercase by using myString.upper. We can convert it all to lowercase using .lower. We can convert it to title case using .title. So these are all methods, and we can split a string based on where spaces are. So if you see in this case, Bob's Diner comes out looking pretty strange. So this is the Python implementation of title, which I don't think is very good, but it gives you a capital B, a capital S, and a capital D. All right, so when we define our function, extra information can be provided for the docstring. So remember the help function, that was really looking up the docstring. So if we want to give a docstring for our function, the way you do it is put a string as the first line after the definition of your function. So it's not stored in a variable, it's just a string standing by itself. And often you'll want to put multiple lines here, so if you use a triple quoted string, then you can put new lines in there, and it will store that as a docstring. The other thing that you can do is you can give hints about what variable types to use. They're not requirements, they're just a hint. So we say, we suggest you provide Celsius as a floating point number, and if you do that, we'll give you back a floating point number. So now if I look at help on Fahrenheit, it tells me that it takes a floating point number as the argument, it'll give back a floating point number, and it gives you this little bit of help here about what it does. You can also look up that docstring if you need to use it in your code for some reason. You do degree Fahrenheit. That should be just Fahrenheit .doc, and returns it, and that'll give it to you as a string, and then you can do something. You can store that string in a variable, you can print it out, and other things which you can't do with help. So even though we've said that Fahrenheit takes a floating point number, we can provide wrong types. For example, we could provide a complex type. And so let's have a look at what that does. So if we say the current temperature is 24 plus 5J degrees Celsius, it'll come back and say, well, it must mean in Fahrenheit that's 75.2 plus 9J. Doesn't make any sense, but it'll still work. And you know, who are we to judge why someone might want to call our function calling Fahrenheit? So we don't want to disallow it in case there is a really good reason that someone comes up with that they need to do this. Okay, define a function which converts the temperature in Celsius or Rankin to Fahrenheit. And here's the formula for converting Rankin to Fahrenheit. Okay, so we can do our function. I'll just call it far again, and it can take either Celsius or it can take Rankin. Now, because it can take either one of these, we have to put default values in, so that makes the other one optional. So let's just set the default values to none. And then we can just test which one is none before we return the value. So we can say if C is none, then we can return C times 1.8 plus 32, else return R minus 459.67. So there's a couple of ways we can call this. So let's say we can print, if we could just put in a Celsius value, so we did before 100, for none type and float. If C, yes, that should be if R is none. Then if R is none, then it runs the Celsius formula, otherwise it runs the Rankin formula. And so if we just put in one number, it knows that that's the C because that's the first number there, and then it will it calculates based on Celsius. Now, how do we tell it to just use Rankin? Well, there's a couple of ways we could do that. We could put a none in the first and just use a positional argument. So I'll say 460 Rankin, and that'll come up as 0.32999 or 33. But that doesn't really look very good. So what we'd normally do is we then use named arguments, and we can say, oh, we want the R value to be 460 and ignore the C value. We just use the optional value for that, and then that works. Alright, so let's look at the solution. The solution's done the same thing. It's created a Celsius and a Rankin value here with nice long names. Now it's done a lot more error checking. First of all, it's checking that we didn't provide both a Celsius and a Rankin, because at the moment, if we provided both, it would just use the Rankin values. So if Celsius is none and Rankin is none, then we want to say, hang on, there's an error, you've got to provide one of them, because otherwise I don't know what to do. And so this is how you create those errors, like you've seen before, like that type error that we got. You can create your own. You say raise value error, and give it a message so that the person who gets the error has got some idea of what they've done wrong and what they need to do to fix it. And otherwise, do the calculation on Rankin because we don't have a Celsius value. Else, so if we're down here, this means we have got a Celsius value. So first of all, we check that Rankin is none. If that's right, we can return the Celsius calculation. Otherwise, we go, hang on, not only have you provided a Celsius, provided Rankin, so with both of those numbers we don't know what to do. So we're going to say that's a value error. Alright, and so let's try running this, and we'll put it all in a try, which means we can catch these errors that come through and do something about them. So there we go, there was a problem. You must provide exactly one of Celsius or Rankin and not both. That happened because we tried calling it this way. And you see it didn't even print any of that print statement. It just jumped straight down to the except and printed the except. And anything else that was in this try code block doesn't even get executed. All right, now I'm not sure if you're familiar with dictionaries. They're a really useful data type in Python. So I'll just quickly go over them. What they are is basically a way of storing key value pairs, and the key can be any hashable value. So for example, you could have here we've got 4 values. Each one is a pair separated with a colon. The left of the colon is our key, and to the right of the colon is our value. So in this case the key is 10, in this case the key is 20, in this case the key is the string THIRTY, and in this case the key is actually a variable name, and the variable, if we look back up here, 40, has got the value 40 in it, the integer 40. So in that case, so this is something you can't do with JavaScript objects. You can't put a variable name as the key, but you can do it in Python. The downside of that is it means when you want to use a string as the key, you have to put quotes around it. But I think that's such a useful thing to be able to have a variable name here that I'd rather this put strings around. I put quotes around strings when they're the keys. Okay, so then I can loop through all the keys in my dictionary and print out the key and the value of the key. So you can see that's how I refer to the value of the key using these square brackets, and the key in there and D with the square brackets means give me the value from the dictionary for that key. Let's quickly have a look at that. So D of 10 is 10, D of 20 is 20, D of 30 is 30, and D of 40 is 40, and the length of the dictionary is 4. Alright, now dictionaries can be really useful when you're looking at arguments for functions. So we've got our function here, and we don't know how many arguments there are going to be. The user might decide to make up some new arguments or whatever, and so yeah, so I just got a quick question here. Martin's about to leave. Yes, the recording will still be available on the YouTube channel, so you can come back later and watch the end of it. So thanks for watching tonight. I'm pretty close to finishing. I am trying to get it within the hour, but obviously I've just got waylaid today. Alright, so we're putting these asterisk here. What that does is it takes all the arguments that the user provides and packs them all up into a dictionary, and the dictionary is called whatever name we put here. We've called it keyword KWArgs for keyword arguments. So what we want is we want to check that only one argument is provided, and we have to check that that argument is one of Celsius or Rankin. So we can do that now. We can check the length of the keyword arguments as 1. We can get the key and get the value for that key and check that it's Celsius or Rankin. and then we can do the right formula, or we can throw either a type error or a value error. Let's try running this. And that seems to work, and we get the value error at the bottom, and we see we've been catching the value error and the type error. But once again, it jumps out before it gets to the once it hits one error, it jumps out of the try code block. So if you really want to catch all the errors, you have to use a separate try code block for each of the lines of code that you're running there. Okay, so now we've got that way of writing code. How can we convert it to accept a third possible argument, which is Kelvin? And there's the formula for Kelvin. I just realized I put a minus there. It should have been plus. Oh no, that's correct. Minus is correct. Alright, so we'll grab our function, and we're going to add in a third one here. So very easy. So we convert Kelvin to Rankin. Value times 1.8. Oh gosh. And subtract the 459.67. That's where the problem is here. That should be a minus there. And let's try calling it. Equals 273. So it should be pretty close to 0, and it is 31.73 degrees Fahrenheit, which is close to 0 degrees Celsius. Yes, and that looks almost identical. Oh yeah, what I should have done is accept only Celsius or Rankin. I should have fixed up that to also say Kelvin, and that's the only thing I didn't do. Alright, so let's have a look at the solution using all this data here, and we'll get all the conversions. They all look good, and we've even got a one here where we're sending in bozos. So let's see, where is it? Fahrenheit. Bozos equals 100, and it comes back 100 bozos is equivalent to type error. Fahrenheit only accepts Celsius, Kelvin, or Rankin, not bozos. Alright, so arguments to a function can have default values. I saw before. Well, you saw in this case they were default values, and separator and end in the print function had default values. Okay, so you'll normally write functions with named arguments, which will accept both by order or by name. So there's a function here converting minutes and seconds to total seconds. And that's a pretty simple function. So if you understand how that works, it just takes the number of minutes times 60 and adds the number of seconds. So expand that to take 3 arguments: hours, minutes, and seconds. So I'm just going to do that. So we'll put hours at the beginning, equals 0 as our default value. And I should really fix up the doc string for this function to now say we're taking hours as well. And let's try calling it. equals 10. Now if I tried to put in seconds here, it was not going to work, because you have to put all your positional arguments first, and so we're going to get this error. Positional argument follows a keyword argument. So we'll put in, we have to call that as a named argument, but the positional, we could just put in a 1 there for the hours, and we get 4210. So that's 3600 plus 60 plus 10. 600, 10 minutes. So it's 3600 plus 600 plus 10, 4210. All right. If we look at the solution, we'll see a few different combinations that we could do. We've got calling all by order, so you just do 3 numbers. You can calling by name, which means you can omit the hours, and you can put the other ones in different order. You can call by order and name, so we'll put our positional first and then our named ones. Or you can just call them all by name, in which case you can put them all in any order that you want. Now you can define a function with unnamed arguments, which means people can't even use named arguments if they want to. And the way you use that is you use the star notation to pack up the arguments. So in this case, a single star, we use double star to pack it into a dictionary. Use a single star, packs it into a list or a tuple, not sure which. So let's have a go with this function. And it's coming out as a tuple. All the arguments are packed into this one tuple when I call it unnamed 4, foobar. Now I couldn't use named arguments because let's have a look at what I do. What happens if I try to giving it a name, and it says it's got a keyword argument args, but args doesn't exist in here. Okay, so task 9, given a tuple of 3 numbers, call total seconds. Alright, so I haven't really shown you how to do this, so with doing this the way that we know, I'd have to call total seconds, and then I'd have to put in the first argument, then put in the second argument, and then put in the third argument. And so that'll work. It'll work if I run this cell first and then this one, and 5535 is what I get as the answer. Now just the way that we can use the star notation for packing up the arguments, we can use the star notation to unpack values that we can use as arguments. So if I called the function with a star tuple in there, it will unpack them and then before it gets used. So you can see that's a useful thing to use as well. And advanced here in Python 3.8 and later, you can define position only and keyword only arguments using slash and asterisk. So this is what it looks like. That's what your standard argument would look like. Position only, you do your arguments here and then you put a slash at the end. Keyword only, you put a star here and then put all your keyword arguments at the end after that. You can even do a combination, which is pos only slash standard star keyword only. But Google Colab's currently only using Python 3.7, so I can't demonstrate that for you. Alright, so that's all we've got for tonight. I hope you found it interesting, and I hope you learned something. I didn't get many questions, but maybe I was just very clear in everything that I was describing. I'm not sure what's happening next week. We've got a Christmas function. If anyone's in Brisbane, look up the Python meetup for that. It's possible that Arun will give a talk on machine learning next week, or we might be having a break for Christmas. I'm not sure. But just keep looking in Meetup, and also we'll let you know on the Slack channel. If not, then we'll get back to it next year. I'll be doing absolute beginners Python on the first Tuesday of the month, and then maybe just a general Python on the second. And Arun will be doing machine learning for every other Tuesday of the month, so you might get 2 or 3 weeks out of him. And it's always really useful, and it's just the most important thing that with these sessions is asking questions. So if you liked the session tonight, please click on like in YouTube and maybe subscribe to my channel. And hope you have a good Christmas. Catch you later.